In this video, we are going to study a ramp signal. So as the name suggests, this signal will look like a ramp. So let us start with the representation of ramp signal in continuous time domain. The equation for ramp signal in continuous time domain is given as R of t equal to a by t into t for t greater than or equal to 0 and 0 for t less than 0. In this equation, this a by t denotes the slope of line. And if we plot the signal, it is time on x-axis, on y-axis it is r of t, and this signal will be a straight line in the first quadrant. If we plot its coordinates, this signal will have amplitude a on y-axis and its corresponding coordinate on x-axis will be equal to t, which determines the slope of this ramp signal. So this ramp signal is always drawn for the positive time values because the signal is represented as a by t into t for t greater than or equal to 0. Similarly, we have unit ramp signal. As the name suggests, it is unit ramp, therefore the slope of signal, which is denoted by a by t, will be equal to 1 in this case. Therefore, the equation of ramp signal, specifically unit ramp signal r of t, will be t for t greater than or equal to 0 and 0 for t less than 0. If we draw the signal, x-axis is time, y-axis is r of t, and this signal will be drawn again in the first quadrant. But remember here, this signal is now unit ramp and it has slope equal to 1. Therefore, if we mark any coordinate on this line, both the values should be same. That is, if I say that a is 2, my x-axis coordinate should be again 2, so that a by t becomes 1. So this is a representation of unit ramp signal in continuous time domain. Similarly, we can represent unit ramp signal in discrete domain. So in discrete time signal for unit ramp, we can denote the equation as r of n equal to n for n greater than or equal to 0 and 0 for n less than 0. And it can be drawn as n, here it will be r of n, and now we need to plot the integer values. So 1, 2, 3, 4, 5 and so on. So if we plot the signal, so remember here, for CT as well as DT unit ramp, the amplitude of signals at 0, at t equal to 0, for specifically now we are drawing it on the discrete domain. So at n equal to 0, I have 0 amplitude. At n equal to 1, amplitude will be equal to 1. So we'll mark the magnitudes on the y-axis. So at 1 we have amplitude equal to 1, at 2 we have amplitude equal to 2, at 3 we have amplitude equal to 3, and so on. At 4 it will be 4, and so on. So this is the representation of unit ramp signal in CT as well as DT domain. The main important point here you need to remember is the magnitude of unit ramp signal is dependent on the time coordinate t. So if t equal to 3, the magnitude will be equal to also 3.